Okay, second example here on algebra notes for 8-3, geometric sequences. And so this one is one of those problems where they don't give you two consecutive terms or two terms right in a row. So you have to do a little math, a little equation solving to figure out that common difference, in this case, the common ratio. Okay, so first off, they're telling me a geometric sequence. So immediately, things that should be running through my head are exponential, meaning that there is a multiplying factor, which is now known as our common ratio. Okay, so they're giving me the third term is 80. So a sub 3 is equal to 80. Remember, I always love to write these out like this because it's just easier to see it in a list. But I'm going to scooch it down a little bit. A sub 3, we're skipping a sub 4, skipping a sub 5. A sub 6, they tell us, is 5, 1, 2, 0. We're missing an a sub 2, an a sub 1. I can immediately tell they're asking me to write an equation, so that means I'm going to need to find my a sub 0, so might as well just set that right up there. Okay, so we know that it's geometric. They tell us that, which tells us that there's that multiplying factor. There's some value, r, that I'm multiplying by to get to the next term, right? That's what it means to be a geometric sequence. So if I'm starting off on the third term, that means that I need to multiply by some common ratio r to get to the fourth term. Then once I'm at the fourth term, I need to multiply by some common ratio r to get me to the fifth term. And then once I'm at the fifth term, I need to multiply by another common ratio to get me to that sixth term. Really easy to make the mistake here to think that, well, there's only two missing terms. I only need to multiply by r twice. But that is not the case. Think about it in terms of subtraction. In order to go from 6 to 3, 6 minus 3 is 3. That's how many of those r's, or if it's an arithmetic, how many common differences you're going to need. So I'm going to use this information right here to make the equation. 80 times r times r times r equals 5120. Well, we know, because we're smart, that r times r times r is r cubed, not 3r, because it's repeated multiplication, and exponents represent repeated multiplication. And we can now solve this equation. If I'm trying to solve for r, I want to get rid of that 80 first, and I'm going to do that. 80 is being multiplied by r, so the inverse would be to divide both sides by r. 5120 divided by 80 ends up being 64. Now, careful here. Do not jump the gun and think that your r is 8, because it's not. Notice we are not trying to get rid of a squared. We're trying to get rid of r cubed. And a square root does not undo a cubed root. But a cubed root, with that little index of 3, a cubed root will undo a cubed root. And I'm going to show you how to get to that in our calculator. So math, because that's our favorite class ever, woohoo! Go to choice 4, see how it's got the cubed right outside of there. And if you were doing something else, if you needed like to the fourth or to the fifth, you would just use option 5, where it has the little x there, and then you can fill in whatever root you want it to be. I'll show you. Except I have to type that in first. So I'm going to clear that out. I would type the 3 in first, then go to math. So again, you can just use choice 4, but I'm showing you how 5 works, and then see how it automatically put that up there. If you have the older version of the calculator, it will just be using parentheses, and it won't actually look like it's raised. And then we learn that the cubed root of 64 is indeed 4, leaving us with a common ratio of 4. So now we can use this to kind of fill in our missing pieces. If I've got 80 and I multiply that by 4, that's going to give me 320. And if I take 320 and multiply it by 4, that's going to give me 1280. And I can double check that that times 4 gives me 521, which I did, or do, or does. All right, so we now know that r is 4. So we now know that we're multiplying by 4, by 4, by 4. So if I want to go backwards from that, I'm going to be dividing by 4 because I need to find that a sub 0. I need to find my y-intercept. So 80 divided by 4 brings me back to 20. 20 divided by 4 brings me back to 5. And 5 divided by 4 brings me back to 5 over 4, or 1.25. So now that I've got my two missing pieces, my y-intercept and my common ratio, I can make that equation that they asked for. So a of n is equal to my y-intercept times my common ratio raised to the n power. And then just again in sequence notation.